Okay, we're back. This is Math Talk here. This is your host, Mr. Friedman. And by popular request, we got a rational function that we are going to graph. So I have given you the position function, the derivative function, and the second derivative function. So have fun. So again, stop as usual. Stop the video, see what you can do. Okay, hopefully you have a very successful graph and you don't even need the rest of the video and you can just stop it now. But in case you are still here and you want to see what's going on or you were having difficulty, let's see what we can do. So as always, we start with the position function and we are going to, so in looking at our position function, we're going to see all the different things that we can find. So first thing, let's go find any vertical asymptotes. So again, in order to find the vertical asymptotes, you set the denominator equal to 0. So we set x squared minus 1 equal to 0. And we should get vertical asymptotes at x equals plus or minus 1. Okay, let's find the x-intercept. In order to find the x-intercept, you set the numerator equal to 0. So we get 10x cubed equals 0. So we got an x-intercept at x equals 0. Next, horizontal asymptotes. So see what you can do. I actually want you to find the slant asymptote if you would. So I kind of gave you a hint, didn't I? I said there's a slant asymptote. That meant that there was no horizontal asymptote, and in the end, behavior was going to positive infinity and maybe negative infinity. So you're welcome for that huge hint. Anyway, doing long division, what I ended up getting, I ended up getting that the slant asymptote was the line y equals 10x. So I think we have everything from the position function that we are going to get. Next, let's go to the first derivative. So for the first derivative, you are going to go find the critical values and what else? Make a sign chart. Don't forget for the sign chart, include your asymptotes, your vertical asymptotes, because we do want to know whether it's increasing or decreasing to the left and right of each asymptote as well as each critical value. Okay, so hopefully you stopped it and you got all the good information that you could find. So let's see what I got. So for my critical values, I took the numerator and I set it equal to 0. And I got critical values when x equals 0 and when x equals plus or minus the square root of 3. So in making my sign chart, I got negative root 3. I also, again, I'm including my asymptotes. I have at negative 1, 0, 1, and root 3. So those are all the different pieces I have to look to. So again, don't forget this right here and right here are vertical asymptotes. So no matter what's going on there can't be a minimum or maximum there. Let's go fill in our sign chart though. So plugging in our values, and remember we plugged them into our first derivative. So I'm going to take numbers to the left and right of negative root 3, and see what I get. So I got, this was positive and this was negative. Now I'm going to look to the left and right of negative 1, which I've already looked to the left of negative 1. To the right of negative 1, it is negative. Now to left and right of 0, again, we've already looked to the left of 0. To the right of 0, it's also negative. So let's be careful. Well, we'll talk about it afterwards, but we're going to be careful. Just you hold on. We'll be super careful. Then to the right of the to 1, it is still negative, and then at root 3, to the right of root 3, it is positive. So what does this tell us? Well, this tells us at negative root 3, we have a maximum. We also have a stall point at 0, right? So there is a stall here because it does hit a derivative of 0, but it does not change sign. And then finally at root 3, we have a minimum. Okay, looks good so far. The only thing that I haven't done, which we should also do, is we do need to get points for x equal for 0 negative root 3, and positive root 3. So again, in order to find those points, we plug those values into our position function. So what I ended up getting was I got the point 0, 0, and negative root 3, and we'll say 15. That's not 15, negative 15 root 3, which is about, I'm going to say it's about negative 26. It's actually negative 25.9, but we'll say negative 26 because who's going to be able to tell, right? And then finally, let's do root 3, and the other one was, again, about positive 26. Great numbers there. Okay, first derivative's done. Time to move on to the second derivative. So stop the video, go find the points of inflection, and then find the concavity. So hopefully you have done that, and let's see. So in this, what I see for our concavity points is there's only one that comes up mathematically, and that's because that's 0. Make sure you understand x squared plus 3 is always positive. The denominator, we already know about those vertical asymptotes, so it's only when 20x equals 0, and that's at 0. So I'm going to make a sign chart, and I'm going to have 0. Now, again, I still want to know the concavity to the left and right of our vertical asymptotes. So I'm going to also consider those. So plugging in numbers into our second derivative, I'm going to plug in numbers to the left and right of each of those. I got, when I did it, I got negative, positive, negative, positive. So that is our concavity. Let's see. What else do we need? We already know the point 0, 0. We actually know all the points. I think we're good to go. I think it's time to graph. So again, stop the video and graph. Have fun with it. Okay, we are back after our commercial break or whatever we did. Anyway, so we are back, and it is time to graph our functions. So let's see what we got here. Oh, this is going to be a huge one. Okay. What do we need? So we have some point. Let's go and graph some more points. So we have a point at, let's see. I've got that x-intercept. Let's get that. Our x-intercept is right here. And I'm going to go and graph my other ones. Normally what I would do, honestly, what I would normally do is I'd graph this, but I'm going to base it on the scale of my other points. I'm going to use that to kind of help me out because I'm really not sure how this is going. You know, these numbers are pretty big. So let's see, negative root 3, negative 26, I'm going to say is about here. And then I'm going to say positive root 3, root 26 is maybe, whoa, right? You know what, I'm going to move these in a little bit. Sorry, I just want to have room. So let's say negative root 326 is there, and positive root 326 is there. So I'm going to label those for your benefit. You are welcome. So we got that, and we got this. Was that super loud? Probably was. Okay. So now I think, anything else? No. Oh, actually, let's get those vertical asymptotes in, right? So we have some vertical asymptotes, and those vertical asymptotes were at plus and minus 1. So I'm going to say maybe about here, kind of estimating, and here. I don't know what the scale of this thing is, right? Who knows? Okay, next, we're going to, I want to kind of go through and let's see what we can do here. Let's take care of our end behavior. So it's that line y equals 10x. So for me, y equals 10x is going to, if you think about it, at my y equals 10x is going to look kind of like this. I'll kind of tell you my logic. Whoa, that was terrible. Look at that. That's just terrible. Oh, makes me so sad. So dotted lines are really hard. Like, you guys should be really impressed right now with my dotted lines. Okay. So I'm going to say about that. And here's kind of basically my reasoning if you're kind of wondering how I figured that out. So it does go through the origin, right? 10x goes to the origin. And root 3, so at about root 3, right, it's 10 times root 3, which is, I don't know, what is that? It's like less than 20. So that's why it lies below those points. Anyway, that was my thinking on that. Not like it was a huge deal, but there you go. Okay, time to go and graph. So what do we got? Looking at our position function, up to root 3, it is, from negative infinity to root 3, it is increasing. And all the way to negative 1, it is concave down. So what does that tell me? Well, that tells me, again, it's going to kind of hug this asymptote. And also, don't forget, there is a, what do we got? We have a maximum at negative root 3. So maybe something kind of like that, right? That's kind of concave down and looks good so far. And then what happens after root 3? It is decreasing and it is still concave down. So maybe something like this. It just goes suddenly, whoa, down like that. That's nice. Okay, so what do we got? So it's concave down and it's increasing all the way to negative root 3, and then it quickly goes down to negative 26. Okay, looks good. Now let's go to the stuff inside the asymptotes. So inside the asymptotes, what's going on? So we have the x-intercept that we know about. Also, from negative 1, it is decreasing. Now remember, these are asymptotes. So it is decreasing. Then after it hits 0, it also decreases. So remember, it's going to cross through the x-axis and is decreasing constantly, but it's going to stall. And not only that, from negative 1 to 0, it is concave up. So concave up and decreasing, stall. And then after 0, it is concave down and still decreasing. So it's stalled and like that. Oh, that is just gorgeous. Oh, man, that's amazing. Okay, last piece. So we took care of that and that and that, right? Yes. Okay. So from 1, so to the right of that asymptote, it is decreasing and it is concave down. So nope, I'm sorry, it is concave up. I was looking at the wrong piece, right? It's concave up. So it's decreasing and concave up after the asymptote. And don't forget, we have a minimum at root 3. And then what does it do? From root 3 on, it is increasing and concave up. So it's going to go along and start hugging that end behavior. And that is our graph. It is gorgeous. I hope you agree. Anyway, that was Math Talk. I was your host, Mr. Friedman. Tune in next time when I make another video. I don't know that's going to be. So next time.